For the first order log difference, we use the calculator, choose the Dutch mark, click on icon D log. First order log difference equal name as DLDM. Turn off the calculators, you get your first order log difference. Now we need to multiply the DLDM by 100. Double click, multiply 100 equal DLDM multiply 100. Now we have our time series data. Second step, we try to identify our preferred model, preferred HAMA model. How to do that? First thing first, we need to put the data into parallelograms. Choose the right variables, DLDM. Put into the selection menus all plot types. Choose the time series property, ACF and the PACF. Choose the icon, plot. Now we have our parallelogram. According to this diagram, we can see our model could be AR1 or AR3 because we have three significant values in the correlation coefficient. So we need to use the overfitting procedures to identify our preferred model. To do this, choose the model. If I go fast, please slow me down, right? Model for time theory, FEMA, formulate, choose the right variables, okay. Choose the estimation method, maximize likelihood. Sorry, I just made one mistake. Right, we need to check the order. Choose the right variable. It will click OK. You need to choose the right orders for AR. We will build AR1 first. Okay? Choose the fixed D. This is the order of integration. Choose the fixed D. Sorry?
Why do you have to check that?
Because we do not study the fractional parameters in this module. We done the unit root test. The integration order is 1, right? If your integration order is 0.6, it means it's fractional parameters. In this module, we only study the integration of order 1. That's why we need to choose the fixed D. Estimation method, the maximum likelihood. Okay, we get our result. In here is our AR1 model. We get a significant value for the AR1, and also we need to pay attention to the AIC, the information criteria. That helps us to identify our preferred model. Once we have the model, the next thing we need to do is run the box or fundamental statistics to check the autocorrelation in the residues estimated from the AR1 model. To do this, test. Choose the test again. Residual autocorrelation, fundamental statistics. Then we get our result. The result is highly significant. The null hypothesis for the fundamental test is your time theory is follow IID. There is no autocorrelation. We reject the null hypothesis. Our residual has autocorrelation. Our model is misspecified. Right? So we need to try to change the number of orders. Order 3. Same procedures. 3 seconds. Yeah. Now we have built our AR3. Once we have the AR3, the next thing is we run the fundamental statistics again. Right? Test. Now we fail to reject the null hypothesis of the autocorrelation test. Our residuals has no autocorrelation. Our model is not misspecified, but we need to get rid of all the unnecessary terms. To do this, we use the exclusion restriction, the WORD test. Choose the test menu, exclusion restrictions. Choose the variables. Now we want to run the WORD test or exclusion restrictions on AR1. The first log value. Click OK. We reject the null hypothesis. The null hypothesis to WORD test is the coefficient is equal to 0. Right? Now we reject the null hypothesis. The coefficient for your log 1 is not equal to 0, so we need to keep the log 1. Repeat this process for each of your logs. We run the WORD test for the AR2, the second log. Click OK. We fail to reject the null hypothesis. The coefficient for log 2 is equal to 0, so we can get rid of the second log. For the third one,
Sorry, how can it equals to 0?
because the null hypothesis is your coefficient of the log term is equal to 0, we fail to reject the null hypothesis, so it will be equal to 0. Okay? For the WORD test, WORD, W-O-R-D. The null hypothesis for the test is going to be here. Your coefficient for your log is equal to 0. So if we fail to reject the null hypothesis, the coefficient for your second log term is equal to 0. So the whole term will be no effect on your whole model, so we get rid of the second log term. Right? Remember recall what is our model? Yt equal to alpha AR1, R1, Yt minus 1 plus R2, Yt minus 2. We get an AR2 model, right? Now, for the WORD test, the null hypothesis is your alpha 1 equal to 0. Right? If we reject the null hypothesis, your alpha 1 will not equal to 0 for rejections. We need to keep this term. Right? If we fail to reject the null hypothesis, your alpha 1 will equal to 0. The whole item will drop. Okay? That's why we need to run the restriction to exclusion test to get rid of all these unnecessary logs. Any questions? Next, exclusion restrictions for the third log. significant. Fail to reject is not hypothesis. Keep the log 3. Right. Now we have identified our preferred model, AR3. Next step, we need to perform an arch test. How to do that? Test menu. For arch test menu, test again. Arch test with order 1. The order is here, so we need to perform arch test with order 1 first. Okay. Highly significant. This test is called Lagrange multiplier test, LM test. We reject the null hypothesis, the coefficient for each. The coefficient for the log squared residues are not equal to 0, so there is arch effect. The problem is we cannot identify the optimal number of logs for arch model, but there is a hint. How to do that? Once we have an AR3, we have identified our preferred model. Use the test menu. Choose store in database. We try to estimate the residue from our AR3. Tick the box residues. Name the variables as residues. Back to our data, you will see we get estimated residues. Next step, we need to calculate the squared residue. Remember, the arch model is dealing with squared residues, right? Calculators, choose your residues, double click, power 2. Equal name as R2. Okay, and again, we get our squared residue estimated from AR3. Next step, we construct the correlograms. We try to build ACF and PACF for the R2. All port types. Time theory, autocorrelation, ACF, PACF. Oh. How many significant correlation coefficients we have? 1, 2, 3, 4, 5, 6. Right? We have 6 significant coefficients, correlation coefficients for the squared residue. In this case, we need to perform the order 6, right? Arch 6. It's not. We don't care. We just care the first 6 because both the ACS and the PACS are significant, right? But this only gives you a hint. It's not 100% accurate to perform arch 6 because there's no efficient method to identify the optimal number of orders for arch. That's one of the weaknesses of arch model. Test again. We go to the test menu. Test. Sorry, no, test somewhere. Test. Choose the arch. Order 6. Okay. Now we have our arch 6. The arch effect. Test the result. The coefficients. Alright, the test result highly significant. Reject the coefficient is equal to 0. So there's arch effect in our squared residue. Once we have identified the arch effect, we try to construct our arch model. Right?
how to construct